Okay, so we want to find the derivative of the composite function when f of u is 1 minus 1 over u equals 1 over 1 minus x, specifically at x equals 1. So what this is basically saying, first of all, when we're finding the derivative, it's asking us, to find the equation that we can use to find the slope, and then specifically then we're going to find it at x equals -1. Okay, so let's go and start this problem. First of all, let's analyze the two parts of these functions. You have the main one, which is 1 minus 1 over u, and then you've got u itself, which is going to be 1 over 1 minus x. So let's find this composite first of all. Okay, so together, if I plug u into f of u, you get 1 minus 1 over, and then u right here. So it's 1 over 1 minus x. Okay, so 1 minus, basically 1 times the reciprocal of the denominator, so 1 minus x over 1. So it's 1 minus 1 minus x. So in a sense of it's 1 minus 1 is 0 and a negative x is x. So together the composite function is x, and if we just quickly take the derivative of this, we're just going to get 1. So in other words, if I want to solve for this specifically at x equals -1, there's no x to plug it in for. It means the derivative is always going to equal 1 no matter what value of x. Okay, so the slope, in other words, slope is always going to be 1 for no matter what x value possible. Okay, now just as a double check, we could, honestly, that would be our answer right there. Okay, but let's do a double check. Let's find the derivative through another way. Okay, the first way I did it, I plugged them together and made the function. The next way is let's actually find the pieces together. So let's find f prime of u. Okay, so if I wrote that, by the way, coming back here, just so I can see the exponents, it's 1 minus u to the -1. Okay, so if I take the derivative of this, it's 0 minus, then drop the -1 down front and subtract 1 from the exponent, so it's a minus 1 u to the -2, or treating this as just u to the -2. Okay, so there's the derivative of that part. If I do the derivative of just u itself, it looks like we're going to have to do the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay, so wipe that out right there. A -1 is going to be +1 over 1 minus x squared. Okay, now remember, to get the overall derivative, we just multiply these two results together. Okay, so f of g of x, f prime of that would be technically u to the -2 times 1 over 1 minus x squared, but we want to get them in the same variable, so let's replace u with what it's equal to. So going back up into here, what u is equal to, I'm sorry, I circled the wrong part, that's what f of u equals. What u equals is 1 over 1 minus x, that way both in terms of x. Okay, well it's, u to the -2 is 1 over u squared, so I'm going to go 1 over my u value, which is 1 over 1 minus x. Okay, so that's 1 over u squared times the 1 over 1 minus x squared. Okay, well, this first part is saying 1 over 1 squared is 1 minus x squared times 1 over 1 minus x squared. And if we just take the reciprocal of this first fraction, you'll basically get 1 minus x, all of that squared, over 1 times 1 over 1 minus x squared. All that cancels out, and again, we're getting a derivative equal to 1. So either way you did it, this way we kind of cleaned up the function first, it became a lot easier. The other way we took the derivative of the pieces and multiplied them together, still worked out to be the same either way, but kind of whichever one you see whenever you start working the problem. Okay, and again, why not go ahead and do both? Sometimes it's good for checks and balance system if you have to. All right, looks like our last problem for this lesson. We want to find the derivative, and here are our pieces. Here's the main function, u plus 1 over cosine squared u, and then we know that u itself is equal to pi x. Okay. As we go about this, my first thought is to maybe try the one where we actually blended together. It seemed to work well in our last one, so maybe keep our fingers crossed, we'll see what it goes here. So let's go ahead and find f of g of x. Okay, so combining the two, u now is pi x, okay, plus 1 over cosine squared u. So it's going to be cosine squared pi x. Okay, and what I might go ahead and do is, just so I can really see all the exponents and I don't have to do the quotient rule, I'm going to go ahead and write this as cosine to the negative 2 pi x, because I don't want to have to do the quotient rule if I don't have to. All right, let's start with the derivative. So f prime of g of x, the derivative of this first one, simple and easy, just pi. Okay. Now, let's do the plus the derivative of the second one. So I'm going to put all of this is the derivative of the second part right here. So cosine to a negative power anyways, let's just treat that as the first thing. So drop the power, subtract 1 from the exponent, and that's that, just taking care of just the exponent part. So now we have to worry about the base part. So now we're going to multiply by the derivative of the base, and the derivative of cosine of any angle is negative sine of that angle. And then to finish up the last bit of the chain rule, then we got to multiply by the derivative of the angle itself, which is just pi. Okay, so this first part up here just takes care of what to do with the exponent on the negative 2, so we drop it down front and just subtract 1. Now the rest of this is just taking care of the base. So the derivative of cosine of pi x is negative sine pi x, and then the derivative of pi x is pi. Alright, let's finish cleaning this up. So we have pi, see a negative 2 and a negative sine is positive 2, and then we have a pi, so I'm going to say positive 2 pi, then cosine to the negative 3 pi x, and then sine pi x. Okay, and that's all of it multiplied together. And if we really kind of want to, we can, so we don't have any negative exponents, we can write it as plus, let's say 2 pi sine of pi x divided by now cosine cubed pi x. Okay, so this is our equation to represent the derivative, to find the slope. And so if I specifically want to find it at x equals 1/4, let's go in here and find that next. So let's see, f prime of g of now specifically 1/4. Okay, so we're going to go to this derivative and plug in 1/4. So it's going to be pi plus 2 pi times the sine of pi times 1/4, so it would be pi over 4, and then cosine cubed of pi times 1/4, so pi over 4. So pi plus 2 pi, and the y value at pi over 4 would be the square root of 2 over 2. And then the cosine value at pi over 4 is the square root of 2 over 2, but we're going to be cubing it. Okay, so pi plus the 2 here is going to cancel with that 2. So we'll have the square root of 2 pi up top. And then in the denominator, cubing the square root of 2 times the square root of 2 times the square root of 2 would be 2 square roots of 2 over 8. Okay, and then kind of cleaning this up in one more step. If you kind of want to, if nothing else, just kind of multiply by the reciprocal of the denominator. If I kind of wrote it like 8 over 2 square roots of 2, kind of chunk that away for just 1 second, so I don't have to rewrite all of this, but the square root of 2 is going to cancel. 8 over 2 is 4. So you have pi plus 4 pi is going to give you an answer of 5 pi. So the derivative evaluated specifically at 1/4 will give you 5 pi.